Welcome back to Robominions.in AI interview preparation app. The topic of this video is generating binary tree from traversals. So before going to the tracing of this code, I request you to watch this video on a laptop with a bigger screen so that you can trace the code along with me. And if that is not possible, at least try to make it as a full screen on your phone, mobile phone, and try to trace the code. Strongly suggest you to watch it on a laptop. Okay. Also, I request you to download the app Robominions.in AI interview preparation app. It's available in the website Robominions.in. Download latest version here. If you have a Windows laptop, download for Windows OS and then click on download anyway. This app will, after watching this video, this app will help you for revision purpose, and if you have an interview or a exam in a day or two and you want to revise all the hundreds of computer science concepts, so it's really hard. So this app will have a clear mapping of all the concepts, so you can quickly revise every concept. Okay, so that is the whole goal of this app. Now let's start tracing the generating binary tree from traversal. So we have a hash include stdi.h, hash include stdlib.h. This arrow will go to the execution line of the specific code. Okay. Then we have a type def struct node. So we have a node for the node of the binary tree has a data value in between. There is a left child and a right child. So there is a left pointer and right pointer. Type def is used for renaming of struct node to NODE, capital NODE. Then we use the node, then we have a declaration node pointer return type generate tree of traversals. So this is a declaration of this function. So it has arguments in order, pre-order, in start, in end. Okay. Then we go to the void main. Here we have a pre-order traversal array. The pre-order traversal array. So when a binary tree is when a binary tree is printed, so you will get this pre-order of the binary tree. So we have already in the video DSA52 pre-order tree traversal, we have already extracted the pre-order from the binary tree. So this is the same pre-order array we are using. Then we have in order. This is the same in order we are using from the video. So from the video DSA43 in order tree traversal. So if you want to know where we got the data, so those two are the video DSA42 and DSA43. So then let's proceed further. We have size equal to 7. Now here node star root. Now root will be the pointer to the root of the binary tree. We will be generating the tree from these two pre-order and in-order traversal. So we will be passing the in-order address of this array and address of pre-order to the pointers. On the receiving side we have int pointer to those arrays, in-order and pre-order array, and we also start the in start and in end. So right now we are sending 0,6, that is size minus 1. So 0,6 will be sent. So then we have pre-index. So this is a static variable in this function. So the value is retained even after when the function goes out of scope. So this value is retained. This will be kept on update. It keeps getting updated. So you have to keep a note of this, how it's getting updated. I will point it out, but remember that it is a static variable, pre-index. Now, as I said, in start is 0, in end is 6, that is 7 minus 1, 6. So 0 greater than 6 is false. So it goes to the next line. It doesn't go inside the if condition. Then we have created a new node. Node equal to, we are allocating the size of node. So allocating memory. So dynamically created a new node. It has a null, garbage value and null. So we add the data. Node of data is pre-order pre underscore index plus plus. Right now pre underscore index is 0. So pre-order the 0 value is 10. So whenever we add the value into the binary tree, we'll make it as green, indicating that so all the data has been added successfully to the binary tree. So that is we have generated the tree from using this traversal. So that turns green. So now 10 is added to the binary tree. Okay. Then it goes if, and yeah, once you can see here, I go back. So when I go back, right now pre underscore index is equal to 0. When after this, there is a plus plus, right? So it will be incremented to 1. So keep a note of that. So yeah, so now it's incremented to 1. Then we have if in underscore start equal to in underscore end. So start and end right now we have passed 0 comma 7 minus 1 6. So 0 equal to 6 is false. So it doesn't go inside the if condition. It goes to the split underscore index equal to search underscore in order. So it's search underscore in order function where you pass in underscore in order and in start in end comma node data. So it will go to the search function, search in order. Here we have a for loop with I is equal to in start and I less than or equal to in end I plus plus. So I equal to 0 less than equal to 6 because in end is 6. So let's go inside if in order of I. So in order of 0 because I is right now 0. So 0 is 13 equal to data. So the data we send is node data. So node data is this is 10. Okay, we are matching in order with the data, the value of in order with the data to find the index. So that is the goal. So let's see what happens now. Now 13 equal to 10 is false. Next I is incremented. Now I is 1. 1 less than or equal to 6 is true. Now it goes to if condition. In order of 1 is 11. 11 equal to 10 is false. Again I is incremented. Now I is 2. Now in order of 2 is 14. 14 equal to 10 false. Again I is incremented to 3. In order of 3 is 10. Yeah, it has matched. 10 equal to 10 is true. So it returns the I. I is 3. So the index 3 is returned to the split underscore index equal to 3. So we have successfully found the split index. So this split index we will be calling the generate tree traversal again recursively for left side and right side. So the tree has to be generated, right? So there is a left side of the tree, right side of the tree. So this split index is used to do that. So now we have found the split index. Now we go to node left equal to generate tree. We send this in order array address, pre-order array address, and again we start in start and split minus index, split index minus 1. So in start is 0, split index is 3, 3 minus 1 is sent to the generate function. So if I click next, remember pre-index has been retained. Okay, remember because it is a static variable. Now it goes to in start. In start is right now 0. As I said, in start is 0. In end is split index 3 minus 1 is 2. 0 greater than 2 is false. So now a new node is created. A memory is allocated here. A garbage value, both left and right is null. Comes back. Now data is added. Node data equal to pre-order of pre-index. Right now pre-index is 1. So 11 is inserted to the node. And after inserting, then pre-index is incremented to 2. See, when I click next, pre-index has been incremented to 2. Then we come to the if condition. In start is 0, right? 0. And in end is 2. So 2 0 equal to 2 is false. Now the split index is called again because this node has its own child, right, left and right. So the split index is called on this node now. So again we call the function search in order. We pass in order array, then we pass the in start is 0, in end is 2, and node data is 11. So node data for right now is 11. So let's go to the search order now, search in order. Yeah, now we have for int I equal to in start, which is 0, and in end is 2. So 0 less than or equal to 2 is true. Then we go to the if condition. In order of 0 is 13 and data right now is 11. So because we are the focus of the focus data is this node. 13 equal to 11 is false. I is incremented to 1. Now in order of 1 is 11. 11 matches with the node data 11. Okay, so 11 has matched with the node data 11. Now this will return the I is 1. I1 is returned for the split underscore index. So split underscore index has got 1. Now again node left is called on this node. So node here, this node is, so node is of this inside this function. So we have node left is this, on which the generate tree of traversal function is called recursively again. So we again send in order, pre-order, in start is 0 and the split index is 1. 1 minus 1, 0 is sent. So when I click next, now you can see in start greater than in end is false. Okay, 0 greater than 0 is false, because in end, that is 1 minus 1 is 0. So 0 greater than 0 is false. Then we create again a new node, that is a node equal to a memory is allocated. Okay, garbage value is added, left child is null, right child is null, G for garbage, and its address is hash 400. Comes back. Okay, node data is now 13 from the pre-order. So pre-order pre-index right now is 2, not yet incremented. So it is 2. So 13 data is added to the node, and when I click next, pre-index gets incremented to 3 because we have plus plus. So pre-index has incremented to 3. Then we have if int start equal to in end. So in start is 0 and in end is 0. So 0 0 equal to true, 0 is true. So it returns the node. So node is returned from this recursively called function. So it will be returned the address of this node, that is return node. So address hash 400 is returned to node left, that is this node left. So you can see when I click next, it has happened. Hash 400 is the address of this node which was returned recursively from the generate tree of traversal function. Now it goes to the right side of this node. So node right. Then we have again we send in order pre-order array, and now split plus 1. Split index is 1. Split index in this function where this node was created, right? Their split index was equal to 1. So 1 plus 1 is 2. In end here, in end here is 2. It was previously 2. When I click next, you will get it. So when I click next, it has gone to the generate tree of traversal recursion. So now when I click next, you can see in start is 2 because split underscore index is 1. 1 plus 1. In end is 2. So 2 greater than 2 is false. It creates a new node. A new node is created. Node equal to a memory is allocated with hash 500. It has garbage value data. And then we have node data is pre-order in bracket pre underscore index. Right now pre underscore index is 3. So this is the data, that is 14. Okay, when we come out of this line, only then that is a post increment, right? There later on it will be incremented. So 14 data has been added to the node. Now pre-index has been incremented to 4, and here in this if condition we have in start 2, in end is also 2. So 2 equal to 2 is true. It returns the node. This node date in this node return node is what is hash 500 address is returned to this node, that is right node right. So this, when I click on next, if you see hash 500 has been the node right has been changed to hash 500. We have successfully linked the left and right child of this node. So when I click next, now what node is this? This is this node. Hash 200 has to go and return and join here. So when I click next, the recursive call of these functions are ending and it is going back here. That is to node left. When I click next, you see node left has ended. Hash 200 address has been added here. The recursive function call of generate tree of traversal has ended, and hash 200 address has been added to the left of the node left, that is node left. Here the split index is 3. In this function the split index was 3. Then we go to the node right, so we go to the right side. Then again we call the generate tree of traversal recursive function. Again we send in order array, pre-order array. Here split underscore index plus 1. Now split underscore index is 3 when this function was called. 3 plus 1 will be 4. In underscore end was 6. Okay, that was size minus 1, 7 minus 1, 6 was there. Okay, when I click next, and you can see 3 plus 1 was 4 and in end was 6. 4 greater than 6 is false. It creates a new node now. Memory is allocated, garbage value, and node data. Now pre underscore index is 4. So pre-order of 4 is 12. 12 data is added to the node, and when I come out of this line, pre underscore index is incremented to 5. When I click next, pre underscore index is incremented to 5, and in if condition in underscore start is 4, 4 equal to in underscore end is 6 is false. So now again, because this node again has child, so we need a split index to find out how the childs are. So when I go to the split index, we go to search in order function. Go to search in order function. We pass the in order array in underscore start, that is 4, in underscore end is 6, node data is 12. So node data is 12 is sent. So that get received in data. So for here we have for int I equal to in underscore start is 4, 4 less than or equal to in underscore end is 6. So 4 less than or equal to 6 is true. We go inside the if condition. In underscore order, in order of 4 is 15. So you can see here we have 15. Data we sent was 12, right? So this data we sent, node data, we sent it here. Yeah, sorry. Search in order, node data we sent 12. So 15 equal to 12 is false. Now we increment I is 5 now. So we check fifth index data. 12 equal to 12 is true. In order of fifth index is 12. So we have found the data in the in order array. We return I. I is what? I is 5. 5 is the split index. So split index equal to 5. Then we call the node left for this node. When we call node left, we have a generate a tree of traversal function recursively called. We send in order array pre-order array. Now in start is 4 and end will be 5 minus 1, that will be 4. So when I click next, you can see 4 greater than 4 is false because in start was 4, split index 5 minus 1 was 4. So 4 greater than 4 is false. A new node is created again. So with the garbage value, node data is pre-order of pre-index. Pre-index right now is 5. So fifth index is data 15. 15 is added to the node. And then when I click next, so once it goes to the next line, pre_index is incremented. When I click next, you see pre_index has been incremented to 6. And here in this if condition, we have in start equal to in end. 4 equal to 4 is true. We return the node. What is the node address? Hash 600. Where will it be returned? Returned to the left child, right? Node left. When I click next, you can see hash 600 has gone and placed in the node left. So this node left. Then we call generate tree traversal for node right. When I click next, it goes to node right. For this recursive function, we had split_index 5. So in order array sent, pre-order array sent, split index plus 1, 5 plus 1, 6 is sent. In end is 6. Okay, when I click next, you see 6 greater than 6. In start, in end, 6 greater than 6 is false. It creates a new node, memory is allocated, has 700 with garbage value. Then we call the node data equal to 16 because pre_index right now is 6. Sixth index data in the pre-order is 16. 16 is added to the node. So node data is 16. When I come after this execution, pre_index will be incremented to 7. When I click next, it has been incremented to 7. And here, if in start equal to in end, so in start is 6, 6 equal to 6 is true, we return the node address. So node address is hash 700. Where does this go? It goes to the node right child. Okay. So when I click, yeah, so it went to the node right, hash 700 has been successfully placed. Okay. So we have finished the recursive calling of these nodes. Now I have to return this node address to this main node. Okay, that is what happens in the next step. Return node. So hash 300 will go and be placed in this node. When I click next, yeah, node right equal to hash 300. So successfully built the binary tree using pre-order and in-order traversal. So when I click return node, it goes to the root. Root is pointing to this binary tree. Then it comes out of the main function. The time complexity of this algorithm is order of n, as we are iterating through all the data of the in-order and pre-order array. Okay. So signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.